Okay. Again, this is all the different possible ways we can look at finding our zeros. So that's a lot of numbers we can test out. And I'm going to eventually teach you guys what's called the Calc's rule of signs that will determine which would be an upper bound or a lower bound. Where does it stop? Where does our end behavior stop? What's the zeros are going to be? But we're going to get to that a little bit later. Okay. Now, when looking at these numbers, the first thing that I would say is do your lower numbers first. They're always going to be easier to do than finding the bigger values. We're going to cheat here because I want to be able to kind of get the rest of this out. Let's go ahead and try our first numbers. We're going to try our first set of numbers. We're going to do synthetic division with -1. We're going to start with -1. We can use 1, but we're going to come to find out that 1 doesn't work. So we're just going to start with -1 here.
But why do we put them under 2?
Factors of 45 over the factors of 2.
What does that do?
One of our factors of 45, these are the factors of 45 over 1, right?
Yeah.
Everything over 1. These are the factors of 45 over 2. Because the factors of our front value is going to be 2 and -45. Leading coefficient and those are possible values. We're going to look at those are possible values we can actually get. It can't just be one set of terms. It might be that those constant values might be none of them. We might not have none that are going to be 1, 3, 5, 9, 40, 15, and 45. None of those might work. Highly unlikely, but they might not work. So we got to be able to use the other coefficient in front of it to give us the possible values. If we're using this, 2, -17, 35, 9, -45. Let's check to see this works. I'm hoping it does. Dropping down our first one here, we're going to get 2. 1 times 2 is going to be -2. This is going to give me -19. This is going to give me 19. This is going to give me 54, right? This will give me -54. This will give me -45. And then this gives me 45. And it does work. It gives me 0. So one of our zeros in our equation will be -1. Okay. It's going to be -1 here. Perfect. Okay. We're going to take it one step down. So we got to be able to do the next terms here. So our polynomial was a degree of 4. So we're going to take these down a degree and give it by 3. So 2x cubed minus 19x squared plus 54x minus 45. And again, do the same process over again.
With the same number?
Well, we got to be able to determine what the possible zeros are. Okay?
So if this factors, is that all we have to do?
Yeah, and that's what we're going to look at the next one. We're going to see if it can be factored. In this case, it's not going to be as nice, but we're going to see. Is this factorable? Is this factorable? 2 and 19 don't have common knowledge, don't have common values. If we pull out a 2, it'll reduce down. 54 doesn't go into 45, so this is again not factorable. If we do it by grouping, we would still not. You would come to find out it's still not groupable. It's still not groupable. So, and it will be eventually factorable, but not yet. Not yet. So we got to do the same thing. And our possible zeros in this case, we got to do the possible zeros again. What we're going to come to find out is they actually share the same ones again. They're going to share the same zeros. The -45 and 2 is the same thing as the 2 and -45. It just it's coincidence. Okay, not going to always be the same. We're going to look at a different one that does something different. But so we don't have to rewrite these because I want to be able to save some room. You don't need to rewrite these. Okay. So the next one that we're going to try out, is let's go ahead and try out our next value of, let's do 3. We're going to use 3 to see if it is a possible zero. In this case, it is because I'm cheating. Instead of testing them and we're trying to find, oh, they're not, we've got to keep on moving. I'm just going to tell you that these ones are going to work because I want to get through a couple problems.
Wait,
2.
so are they going to be this big when it's by ourselves and we have to test like all of them?
It is possible. It is possible. It is possible. This is what, it's not difficult to do, but it is It's time consuming. They're not difficult to do, it's time consuming. And that's my hesitation to give you something with a degree that's higher. And I'll show you one that's I think would be a good one to give you. Okay, I'll show you one that's a good one to give you. If we do this one, does it reduce down nicely? We're going to get 2. 3 times 2 is 6. Negative 13. Negative 39. We're going to get negative 15. Positive 15, I'm just kidding. We're going to get 45 and 0. So we ended up finding out that 3 is another 0. What a coincidence. I'm a genius. I'm just kidding. I just knew it to be it. Okay. Again, we would take our terms again, and I'm going to rewrite it again. Okay. We know that it reduces down, so let's reduce it down one more time. 2x squared minus 13x plus 15, because we're taking it down by 1 degree from every quotient that we have. Our quotient is 1 degree less. And now we want to be able to look up here and go, is this factorable? Okay. It is factorable, so we can reduce it. So let's look at our advanced snowflake for this. We take our last two numbers to get 30. Inside to give us negative 13. What multiplies to give us 30 but adds up to give us negative 13? Negative 10 and negative 3. Okay, negative 10, negative 3. If we wanted to be able to write these out as factors, this can be reduced down to x and 5. This is going to remain the same, 2x minus 3. So these are our factors. So x minus 5 is one of them. And then this is going to be 2x minus 3. So now we got to write everything out. We got to be able to find out all our values. So x, all the zeros for this polynomial degree, that's 4 with all of our terms. We want to be able to look at our synthetic. What was one of them? Negative 1 was definitely one of them. 3 was one of them. And then we look at 5. And if you were to solve this, we would solve it as 3 over 2. Okay? Which, Ms. Garcia, if you're looking at this, if we were to continue this idea, and you did know this was factorable, you would actually have to plug in 3 over 2 would be a possible 0 for this. Right? So we still have to have those in there. Right? It should give us nicer numbers in order to factor us out. Right? Would I ever give you one that would be all fractions and all zeros? Have I given you one yet? Okay.
Do you want us to rewrite like x plus 1?
I'm going to show you right now.
Oh.
Yeah. Okay. If I want to continue on and write these all as factors, once we have our zeros here, we'd be able to write them out. X plus 1, x minus 3, x minus 5, and then our last one, which is 2x minus 3, which we're just using from our original. So this is the factored form of the original polynomial. This is what it's helping us out. Is it kind of making sense? Are we kind of being clear with this? The more that we do, the better we come at. Okay. We're gonna change it up right now. We're gonna change it up because what would happen if this was unfactorable? What happens if this is unfactorable? We have to do the quadratic equation. That's all we're gonna do. So we're just gonna add to that. This is all you missed. Welcome back. Welcome back.
Do we have to put the x plus 1 x minus 3?
Only if I ask you for the factors. I think I will, only because I think it's an easy point to get to your test. I think it's kind of easy, right? I think it's kind of nice. And we can stem from this, and I can show you different things like, is there any multiplicity of 2? What's the multiplicity, right? We could talk about that as well. What term has a multiplicity? So let's get to that. Hold off, give me a second. Let me make sure that this is the one I want to do with you guys. Okay, absolutely, this is the one. Copy this one down. Okay, copy this one down. This is a really good problem. It might be a really good test question. It's a really good test question. This would be a really good test question, but I'm just saying that. I might put in something very similar, but it might be a really good test question. Okay. Something very similar to this might be really good. Just saying. Okay, just saying. So this is going to kind of help us do several things about this. And what makes this a really good one is I'm going to show you guys. I'm going to show you guys why this one, even though it's a degree of 4 polynomial, this might be a really good test question to put down. Can I be any more clear? I don't know if I can. I'm trying. I try. I try. I don't want you guys to freak out. Does any other friends are freaking out over the other classes? How do you guys feel about my class? You freaking out a little bit? No? This class?
Well, up to for a week, I still have an A in this class. So.
You're good then. You're good. Sorry. You come to find out in life that what you can think you can be better at everything, but you come to find out that you're not. It's a very humbling experience. Yeah. It's okay. I'm not good at a lot of things. Spelling is one of them. Come to terms. I'm not a good reader. Hi, my name is Mr. Aguilar, and I'm not a good reader. I'm okay with that. I've come to terms. Pretty outgoing guy. It can be a good time at that. Okay. Don't like reading. Sorry. How many books have I read in the last 4 years? 0. I don't read at all. How-tos I can do. I can fix a car really nice. I can install a subsystem in the back. Can't do anything besides that. Okay. So what makes this one really nice is let's look at all the possible zeros. What's our possible zeros that we're going to look at? Plus or minus 1, plus or minus 2. This is doable, right? Because these are a lot smaller, you're only doing synthetic division 4 times. This would be something really nice to actually try out, right? You know, you could try them out on these ones. On a test, you'd be able to do 4 of them. This is what makes this problem nice for a test. Okay. We're gonna cheat again just because I know the values, because I want to get to what the real part of this is doing. And we're gonna look at this type, and let's go ahead and try. What's one of them that we're gonna try out? 1 or -1? Check it. Hold on. Check it again. Let's check it. We're going to do 1, -5, -7, 13, -2. Let's see if you did it right. This is just good practice to do synthetic again. Yeah, it's okay. We're going to drop down 1. 1 times 1 is 1. -4, -4, -11, -11, 2, 2, 0. So 1 does work. What a coinky dink. Okay. Again, when we get a quotient that has a remainder of 0, we want to rewrite it out just so we can see the polynomial itself. Do you need to do this step? No, but I would highly recommend you do it just so you're understanding what's happening here. Minus 4x squared minus 11x plus 2. And we look at this and we go, can we factor by grouping, right? Because we learned how to factor cubics like this. Can it be factored by grouping? We're going to come to find out again it doesn't. This can't be factored out by grouping as we would like it to be. So again, we're going to do the same thing. What are our possible zeros of this? And this one's nice to write down again. 1 and 2. So we'd be able to do this one again. Okay. I'm going to tell you right now for a little trick is if we already did one of them, you could pretty much skip the first set of groups because they're pretty much the same equation again. So you don't really need to do one. You can switch to the next row. This is why we did 1, 3 because we didn't have to do the same parts again. Here's the one we're going to try out. We're going to do 2. Does 2 work? Some of you guys did 2 already. We're going to do 1, -4, -11, and 2. Does it work? No? You sure? Let's see. 2, 4, 0, 2, -9, 18. Doesn't work. Okay. Which one are we going to use then? If we did 2, we have to do -2. So we can do -2. -2 does work? So try this on the bottom down here. We're going to get 1, negative 2, negative 6, 12, 1, negative 2, 0.
Why is that 2 anything at the bottom? On the example?
Oh, because I didn't do it right. That makes up things too. Did this mess it up? I'm sorry. I thought this would work. 2, 4. No, why do I keep on messing up with 2? 1, 2, negative 2, negative 4, negative 15. Still not 0. It's okay. Even I make mistakes. So again, we would take our bottom term down here. I'd rewrite it up here, and I'm going to write this as x squared minus 6x plus 1. Now this is a question we got to ask for ourselves here. Is this factorable? Think about it. What multiplies to give you 1 but adds up to give you negative 6? What multiplies to give you 1 but adds up to give you negative 6? Doesn't work. Okay. Now, when we get something like this, we could still solve for our x's, right? We still got to be able to solve for our x's. And like we said before, if you get stuck here and we cannot factor this, we got to be able to use quadratic equation. So I don't know if I need to provide you guys this. I'm pretty sure you guys remember this, right? Hopefully, negative b plus or minus square root b squared minus 4ac all over 2a. If we plug in our values, negative 6 times negative, negative b times negative, or negative times a negative 6 is 6, plus or minus square root. B squared is 36. 36 minus 1, 4, all over 2a, negative 2, 2, 2. We're fine there. We're going to reduce this down. It's positive. It's positive. Sorry. Just checking. Just checking. Gosh, you guys would be so mad. I'm just kidding. Seems you guys are paying attention. Yeah, that's it. 6 plus or minus square root of 34 over 2. Now, 32, Jesus. I'm trying to get ahead of myself. Okay. These are our possible values. Now, can we reduce this down? You can reduce this. You can if you want to, but I'm okay with you leaving it like this. Okay, I'm okay with you leaving it like this. And the reason why it is because when people start reducing these down, this is where they mess up. I understand you get how to reduce, right? This becomes, what is this? 16 radical 2, so 4 radical 2, right? We can pull out a 4 and we can reduce down. Just leave it like this, please. It makes, I could see where you went wrong here rather than doing an extra step. Most people make the mistake after this. So if we had to do our possible zeros, and I'll put this up here in the corner up here, what are our possible zeros in this case? What are the zeros? X would be equal to negative, or 1, right, for our first one, negative 2, and then 6 plus square root of 32 over 2, and 6 minus 32 over 2. So these would be the possible zeros. Yeah, that's fine. I just want to show you that we actually have 4 solutions for a fourth degree polynomial. Okay. Yeah, you can do the plus or minus. You could have left it like this and just added it to the top, but I'm just showing you the extra stuff. Comprendo? Is this making more sense the more we do it? Okay. Here we go. Let's try another problem out. Why is it getting so freaking cold in here? Okay. Copy this one down. Now, before you write the synthetic division for this, please hold on, because it's something I got to go over. Okay, before you do this, write down, do not do the synthetic division first. But write down what you think the synthetic division, like the problem would be. Meaning, how would you first write it out? Right, 1 divided 1 over whatever, or however you want to write this synthetic. Do not solve it yet, because a lot of you guys are going to do this part wrong. I'm hoping you guys just heard me say that because you guys are going to look at it. What are possible zeros? What are possible zeros? It's 2. Is this doable? Is this going to be doable on the test? That's doable. It's not 20 problems long, but it's doable. I'm okay with doing this one. I don't know if it will be, but it's possible. Now, one thing that we're going to say here, because I already know how to do this, because we already know how to solve these ones out, I'm going to go ahead and let's go ahead and just start this one out. Let's say we're going to decide that it's going to be let's try -1. What would I write for the inside of that synthetic division? Does anyone know how to put 0 in there? It's missing the x squared. So this is why I wanted you guys to hold off, right? Right? Because I wanted you to hold off. Because I know some of you guys are going to do it like, oh, -1 doesn't work, right? The zeros has to be a placeholder for the x squared term that's in here. So you got to make sure that you remember putting this value in. So if it's not in there, you got to put it in, or else your problems are going to mess up. Will -1 work? Does it work? Okay, let's check it. Again, the only reason why I'm doing this is the more practice you do with synthetic, the more you're going to get good at it, the faster it's going to be. Right? Boom, boom, boom. You can do it in your head. -1 is 1, 6, -6, -6, 6, -4, 4, 0. So, -1 does work. Kudos to you. Kudos to you. Let's take it one more step down. We're going to write out the polynomial for this. What degree is it going to be? X to the 3. So -x to the 3rd plus 6x squared minus 6x minus 4. Okay, let's look at the possible zeros again, just because I want you guys to get used to writing them out. If we're looking at the possible zeros, we're going to get plus or minus 1, plus or minus 2, plus or minus 4. And again, you could try these ones out again. We're actually going to find out that it's going to be our next value for this, our next value will be, let's try 2. Again, I'm cheating. Will we have to test? Yes, but I think you guys know how to test. Right? You know how to test by now. I'm okay with not testing. We're going to use the polynomial up above, -1, 6, -6, -4. Let's use synthetic on this one. Does this one work? -1, 2, 8. Is that good?
-2, that's why. It's 2 times -1 is -2. Yeah, or
Okay. So I just made a boo-boo here. Sorry. -2, right? -2, 4, 8, 2, 4, 0. As you can tell, you can mess up. Even I'm messing up, so you can definitely mess up on these. So it's okay. That's why we have calculators. I'm going to let you use calculators on this. So do me a favor and write this one out. Write this one out for our polynomials. We've got to be able to check what the below. It was fun. Hey. Questions? Yeah. 8 in the morning? Yeah, if I can get it covered. Yeah. No, not at 8 o'clock in the morning. No, 11? I think I have it. Yeah. Cool. Let's do it. Yep. Yeah. Sounds good. Is this factorable?
No.
No. When we rewrite it out, we're going to rewrite the little jewel up here. The jewel that we're going to get is negative x squared plus 4x plus 2. Even if you were to pull out a negative in front of that, this would be is this factorable? Multiplies to give you negative 2, adds up to give you negative 4? Not factorable. Not factorable. So even there, so we're going to take our values now. This doesn't work, so we got to be able to factor it out using our quadratic. Negative b, I guess that you know how to plug it in. So I'm just going to plug it in directly. Negative b, negative 4, plus or minus b squared, 16, minus 4ac, 16 minus, so it becomes plus 8, all over 2a, so negative 2. If we reduce this down, our negatives can go away, giving us plus 4, 24, right? 24. Extra zeros, right? That's what we got. Our final solution will be, and I'll just write this out, x is equal to negative 1, 2. And can I just put the plus or minus, or you want me to write the whole thing out? Okay. Good stuff? Making more sense? Our negatives going to actually cancel out, right? Negative and negative here. Those can, because I want to see if it was still factorable. I'm just testing. Well, maybe I can pull out an x and it might give me something nice that I can work with. Yeah, I'm still plugging in the original values. Yeah, I'm still plugging in the original. Yeah, I just want to test it. Maybe it might just be able to pull out a negative or pull out the greatest common factor to see if it's factorable. Sometimes that might be the case. So use all your methods that you can use. Yeah, because sometimes it's going to be nice, sometimes it's not. Kim, how much more time do we have in here? 5 minutes. Can I give you guys your work then? Do you guys want to just have that? Okay. Okay. I would hold off real quick. This is hold on, give me 1 second. 21, 23. So the ones that have the arrows to them have the answers to them already. The only one that you're really not going to do that doesn't have really anything to it is 42. So keep that in mind as you guys do these. I'm giving you guys the zeros to start out with to kind of help you out, but still follow the same process. What is all the zeros? What is all the rationals? What are all the, right? So I want you guys to list all them. Can you guys do that for me? So do the same process. I'm giving you the answers, so it's spending less time doing them, but I do want you guys to be able to provide me the work for it. Show me synthetic division. Show me the quadratic formula. How does it get those answers? These ones, I believe they do reduce for these ones. So just keep that in mind as we do them, okay? And I'm going to give it to them like this whole week. I'm going to give you the answers that correspond to them. Because that goes back to Brenton, right? Brenton, you asked me about those, about giving you problems that kind of correlate. I think we talked about that. Because you guys can go back and look at the answers and what they mean. So just keep that in mind.